All right, Dana, I'm going to show you how to do the 22, 23, and 24. Let me open my notes so I have a notepad to write on. I don't know what those words are, so we'll just make a new page. And then we'll pull up Seesaw and I'll go to the problems. Whoops, sorry, Dana. All right, so it says, Paige bought 5 old CDs at a garage sale. If 3 of the CDs were scratched up, how many good CDs did she buy? So this is a bunch of mixed problems. So they might be multiplication, they might be division, they might be subtraction, and they might be addition. So it's going to take you to figure out what math action is involved. So remember when we do multiplication, we have equal groups, and we're trying to find the total. And then if we have division, we're sharing from the total. So we know the total and we're sharing when it's division, when it's multiplication. When it's subtraction, that means we know the total and we're taking away part. And when it's addition, that means we know two different parts, and we're putting them together to find the total. Remember, multiplication is like addition, but equal groups, and subtraction is like division, but equal groups. So here we know that Paige is buying 5 CDs, and 3 of them are scratched up. So she bought 5 total CDs, and then 3 of them were scratched. We want to know how many good CDs did she buy. So if she bought 5 and 3 of them were scratched up and didn't work, that means they're bad. So she has 2 CDs left that are good. So that's subtraction. My answer is 2, and I got the right answer. Here it says Dave bought a crayon box with 12 crayons. If he accidentally broke 7 of them, how many unbroken crayons does he have? So we know that he bought a box and there were 12 total, and then he broke them, right? And you don't want to use broke crayons, so you put them away or you throw them away. That means you take away. And they want to know how many good crayons were left. So I go 12 minus 7, and I could do all my regrouping, but it's going to end up being 12 minus 7 again. So I'm going to go 12, 11, 10, 9, 8, 7, 6, 5. So they had 5 good crayons left, 5 crayons that were not broken. So you have to read them and see which type of math you're going to do. Most of these are pretty easy word problems, so it shouldn't be too hard for you. Let's go back to Seesaw and see what is 23 is determining factors and multiples. Remember factors, we go, let me erase better. Remember, factors are when we're multiplying, we go factor times factor equals the product or the answer. So factors are the numbers that are multiplied together to get an answer, and multiples are when we skip count. So multiples are skip counting. Okay, so it says which number is a factor of 14 but not a multiple of 2. So when I multiply the 2 numbers together, I get 14, but I will not count it when I count by 2s. So when I count by 2s, I go 2, 4, 6, 8, 10, and none of these are over 10. So I know it's not going to be 4 because that is a multiple and it does not want to be a multiple. But it could be 7, because 7 is not a multiple of 2. It could be 3, because 3 is not a multiple of 2. And it could be 5. Oops, sorry, 14. But if I multiply, I have to get 14. So we know it's not 4. Can I go 7 times something to get 14? Yes, 7 times 2 is 14. So 7 is a factor of 14, but not a multiple of 2. Let's see if another one works. Can I go 3 times something to get 14? 3, 6, 9, 12, 15. Nope, I don't land on 14. Let's try 5. 5, 10, 15. Nope. So the only one that works is 7. So I pick that one. Go to the next one. Which number is a factor of 15, but not a multiple of 3? So I need it to equal 15, but it can't be a multiple of 3. So let's see the multiples of 3. 3, 6, 9, 12. And none of them are over 12, so I'm not going to keep going. Let's see. It can't be 6 because 6 is here, so it's not going to be 6. Let's see if we could do 8. Is 8 times something 15? 8, 16. Nope, it can't be 8. Let's try 5. 5, 10, 15. Yep, it could be 5. But let's try the last one just in case. 4. 4, 8, 12, 16. Nope, it can't be 4. So it has to be 5 is the only one. And I keep going. So remember, it has to equal 16 or equal the first part when you multiply it. But it cannot be a skip count of 4 or whatever the last number is. Okay? So let's look at our last one. Is identifying prime and composite numbers. So prime and composite numbers, remember, let me erase all of this work for the factors and multiples. Prime means that a number can be multiplied by itself and 1 only to make it. So prime is 1 times a number. Composite means that you can multiply different ways to get the answer. So many different equations or multiplications. So 7, I need to go something times something equals 7. If I can do 2 ways, it is composite. If I can only do 1 way, it is prime. So let's see. I know that 1 times 7 is 7. Can I do 2? 2, 4, 6, 8? Nope. Can I do 3? 3, 6, 9? Nope. Can I do 4? 4, 8? Nope. Can I do 5? 5, 10? Nope. Can I do 6? 6, 12? Nope. And then the next number is 7, and we already have 7, so 7 is prime. We can only make it with 1 and itself. And then we'll go to the next one. The next one is 47. What ways, are there 2 ways I can make 47? Let's see, 1 times 47, yep. And then, could I do 2? No, because remember 2 has to end in a even number and 7 is an odd number. So let's try 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Nope. Let's try 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Nope. Let's try 5. Oh, I don't need to do 5 because remember all 5s end in 5 and 0. Try 6, 6, 12, 18, 6, 12, 18, 24, 30, 36, 42, 48. Nope. 7, let's try 7. 7, 14, 21, 28, 35, 42, 49. Nope. 8s, 8, 16, 24, 32, 40, 48. Nope. 9s, we go 9, 18, 27, 36, 45, 54. Nope. So I'm going to say that it's prime. I already went up to 9 and I couldn't find any. Let's check my answer. Yep, I'm right. 75. Ooh, since 75 ends in a 5, I already know that it's going to be composite. Because remember, it can go 1 time, whoops, sorry, that's Logan's 5th grade work. 1 times 75 is 75. And then since it ends in a 5, it can be multiplied by 5. So I can go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. 5 times 15 is 75. So I know it's composite because I can make it in 2 ways. So then I will keep going. If you would like to, you could always pull up, if you're having trouble with prime and composites, you can always pull up a list, or well, you could go 100 chart of prime and composite numbers. But remember, you need to know these for middle school because you're going to be doing something called prime factorization. And so you need to be able to know all your factors until you get all prime numbers. But in the meantime, you could pull up the hundreds chart. You could just search for one. And this tells you all the prime and composite numbers. So all the numbers that are pink are composite, all the numbers that are white are prime. I hope that helps, Dana.